thanks for staying tonight. I try to make this as entertaining as possible. So first, to get into that, who of you knows what Otto actually is and does? Many people, that's good. So first message is, hi, we are still here, alive and kicking. We stopped doing the thing with the big paper bag. So like last year was the last big paper bag that we actually sent out. And maybe for those who don't know Otto, we are a German e-commerce company, actually the second largest German e-commerce company. And we are also the German market leader for home and living in e-commerce. So, and we started 70 years ago. Like 70 years ago was a year when Jeff Bezos was not even born. And 70 years ago you could buy shoes and some pair of pants by calling Otto and ordering things. And you can still do that, right? You can still call us, but we also did the digital transformation pretty well, so we are not done yet. Of course, no one is done yet, but we are still alive and kicking, and this is actually makes us a bit different than all the competitors that started with big paper bags. And one of the reasons is that we invested in data-driven decision-making and automation. And one of the results are cool innovation projects like the project I'm introducing to you today. So this is basically a summary of many data meetings that I attended. And of course, there's always me with being the one having so little data. So I previously worked at a German publisher. We had no data at all, right? And now in a small German e-commerce company, you have a bit more data, but not so much. And then there's some show-off, probably from the automotive industry. I'm sorry, is anyone is from automotive? So. And they have, of course, tons of data and tons of money to process this data, and they are all better off than we are, of course. But I want to change the world of those meetings, because actually what happens afterwards is this. Right? So overfeeding your AI does not have necessarily good results. That's the point I'm trying to make. And apart from this illustration, there are also other reasons why having too much data is actually not such a good idea. This is the classic one, right? And this is basically, this slide is the only reason why I came by train, I swear. So I can't talk about making more emissions by having more data and then fly, but actually the whole data traffic that we have with the internet and streaming and data processing causes more carbon emission by the meantime than air traffic. And the internet has a large, it's really energy hungry, and data is growing exponentially every day. So the problem is actually known. So data centers try to get greener and try to cool their stuff by building them in caves. But we say, okay, maybe only tackling hardware and software solutions is not the only thing that you can do. Then this is about data minimalism, right? But you want to have as little data as possible to make the world a better place. The other thing is data value. So I think you can learn from the best people that use data for their living, namely people that steal data, right? They make a lot of money with data and they don't do anything else, so they have to know it. Data breaches actually grow with the amount of data that is there. That means it must be worth it to do this, because, well, it's basically illegal, right? So you take a high risk. But on the other hand, this high risk is not necessarily proportional to the amount of data that you dig out. So sometimes it's actually worth to get only a little data and take all the risk for just a few data records. And if those people that know everything about what data value actually is, because that's their business, even if it's an illegal business, then there must be something to it. And that's what we are getting at now. The first question that we actually ask ourselves, so how much data do we actually need? That's a well-known question. If people start with artificial intelligence or data-driven algorithms, the first question is always, so how much do I need actually? How much annotation do I have to do? How much do I need to put in? And of course there's no good answer, but there is one type of thinking about the answer, and this actually, for all the people that also studied something with machine learning in it, you know this, right? This is the standard curve for machine learning. This is basically from the books. And I'm so happy that spending so much time at the university for once taught me something useful in real life. So for those of you who don't know this curve, that's like with exercise, right? If you're a couch potato and start exercising twice a week, that gives you a huge push forward. But if you are already exercising like 4 times a week and then doing it 5 times a week, does not make so much of a difference. It's the same for machine learning. In the beginning, if you have 0 data, putting in data helps a lot. And if you have already a lot of data, then this flattens out. And what you want actually is some point where you actually have a good efficiency of your data, because data is expensive, of course. You have to work with data, but you also want a good quality system and make good decisions. So, we take some assumptions here. Of course, we have the assumption everything is automated, right? So human-generated data value is not what I'm talking about today. I don't deny that this exists, but it's just not in the scope. And the second thing is, you know what actually a good performance is. And this, of course, is not self-evident. Sometimes you just don't know what a well-performing AI or a well-performing system is, but there are very good reasons to actually ask this question and answer it formally. And for us, of course, at Otto, measure performance means measuring money. We want to know how much money does actually a system make. So when I talk now about performance, I usually mean making money, right? That's easy. And at the end of the day, I want to get as much money out of my data as possible. I want to be with my system somewhere here. I want to put so much data in the system, it's reasonably good, but not unnecessarily expensive for what I'm getting out. That's the point I'm looking for. And this curve will show up later on. So I'm really happy that the previous talk was not too deep diving into tech, because now I can do all the tech stuff. What do we do for a case study? We take a recommender system. So probably most of you have seen a recommender system in their lives. If you ever have been at some e-shop, you know what a recommender system is, right? Other people also bought, and you have this product, and you probably want to buy this product too. In our special case, we don't say customers who also bought also want this item, but who also clicked this item. So for us, this is view-based, not buy-based, so to say. And to actually find out how many customers we need to make decent recommendations to other customers, we did a pretty large experiments and wondered, okay, we have our full system with data, let's just simply check if we give the system a little less data, say like 10% or 20% or 30%, what would in theory happen to our money-making machine? Will it make less money or not? It's actually pretty easy. And for those of you who are into that nerdy stuff, for computing recommendations, we actually use the word-to-vec algorithm from Google. So what we do is building a vector model out of clicks of customers. So every customer that comes to us is actually produces a so-called user session. So people come to the site, click around, look at products, and those user sessions we use to find out what other people could also look at when they see a product. And what we do then is, yeah, right, look if a few customers do the same job for producing such recommendations as many customers could. And now comes the sad part of my talk. That's a really sad part. So it starts actually pretty harmless. Let's look at computing time, because time is money too, right? If you can really frequently train a system and retrain it and keep it up to date, that's a good thing. And this is not surprising at all, right? If you put more data into the system, training the model takes longer. So that's not new, so not really exciting. Also not really sad, right? That's not the point, and there could be interesting story to tell about this spike in the middle, but that's beyond the scope now. Then there is a boring thing, because this curve you have seen already, right? So if we put more data into the system, we see this learning curve. This learning curve actually tells us all the recommendations that have been computed in theory, because we can't now put it to customers. The problem is if we go to the people that actually make Otto.de and tell them, look, we want to make a really bad recommender system, and you should put this on the page for an A/B test in order for us to know how much money this would make. This is not a good idea. We cannot even ask. So we did this in a theoretical way. We actually checked what people really bought when they clicked on articles and when they saw those recommendations that we computed in theory. And we thought, okay, in our lab, we think that customers would behave the same way that they actually behaved online. So we take real click data to evaluate how good the system is. And that's also the way how we computed actually revenue. So things that were actually bought for us, we think they would be bought in our lab too. So, okay, so much for the normal thing. After some bit of data, this is not as effective anymore as at the beginning. That's still boring, and now the sad part is we look at conversion rate. Conversion rate means a customer sees a recommendation, so a different user also bought, clicks on it and buys it immediately. And conversion rate is the percentage of times this happens. Usually this is pretty low, but it tells us a lot on how interesting was this recommendation. It's a kind of relevance measure, so to say. And what happens is this. This was a very interesting and very sad day. We said, okay, maybe we could save a lot of money if we had known this before. So the thing is, in sum, we still make more money. Why do we do that? Because we have bad recommendations, they really get worse, but we have many more recommendations. Because more data means we have more different products for which we can compute recommendations. So in Germany you would say Masse statt Klasse. We have a really large portfolio of products for which we can compute recommendations only. Those recommendations turn really, really bad in the end. So, and actually that's not what we want. We want to be somehow smarter than this at the end of the day. And we try to do this, and by asking which is the data that actually counts. So the 30% that you have seen, which 30% can we take? Because just cutting away from a timeline or something is probably not a smart idea. It's not any data, it's a certain informative part of data. And bear with me. I know most of you do something in tech, but this is a management illustration actually, which works pretty well. And I like to show it because it's like colorful and says us actually the problem is. So if we assume that we have a customer and a hungry robot that wants data to compute recommendations, right? Then there are two alternatives. The first thing is the customer comes and clicks on something that's really boring. Say the daily deal or the first page. It's boring because 1 million people will do that after him, 1 million people did it before him. We don't learn anything new from this. And the other thing is, if someone goes to the site and searches for something and clicks on a new product, we learn a lot from this actually. Because it's new information and we can make, out of this information, we can make money. So, and this means that we have data points. And now somehow the metaphor somehow switches, right? Now the salary is the bad thing and the burger is the good thing, but whatever. Of course, you want nutritious data for your data robot, that's the thing. And we did a similar experiment to the last one, actually, something that's called sensitivity analysis. You might know that from other data science contexts. So people did, for example, sensitivity analysis to reduce databases to avoid bias. So if you have the problem, for example, of medical systems, then you have many more healthy people than sick people, and that is a problem because the system tends to judge everyone healthy because just there are so many healthy people. And what you can do, for example, next to many other techniques, is reducing the amount of healthy people in your data set. And this you can, for example, do with sensitivity analysis and finding out which of the healthy people are actually the most representative or best data points for your system. And that's basically what we do too. So we have the whole system that we had before, and then we take single data points out of the system. So we're really one record. We strike it out. And we don't do this just once, but 500 times. Of course, we can't do this with a full-blown 9 terabyte system. That wouldn't work. It's simply not feasible. So we have a lab scale. It's more like, so usually we have 6 months of data, and this is like 2 days of data. And then we check what happens. Is there a difference? So many people actually predicted 1 data point, forget it. That can't make a difference. And in many cases, they would be right. So if this wasn't a machine learning system, but for example, a simpler regression system or a system where you just count by things, 1 data point would not make a difference at all. Actually tested. So it does not make a system difference at all if you have such a system. But if you use a machine learning system like Word2Vec, that is based on neural nets that do some fancy stuff with some fancy random things that you actually are hard to grasp, then 1 data point can make a huge difference, as we have seen. So we have a really small system, and the system is still in its early stages of learning. So in this curve where data does a lot of good, we are still really early. So most of the data actually helps the system to get better. That's good news. But 11% of the data, so like 10%, even make the system perform worse. And nice example for such data that make the system perform worse is actually robot data. Sometimes people send robots to auto. They just click around frantically, and sometimes those robots even promote products from their own company. So we had a robot clicking on really horrible shirts with horrible prints, and everybody thought, okay, why is this recommended at all? It's really, nobody buys this shit. But the problem was, and we learned it only afterwards, this is just a bot that keeps clicking all the time. And things like this actually hurt the performance of the recommender, even if it's just 1 session with a lot of clicking. And this is the red stuff. And then, of course, there is a part of data about 1/4 that is just nothing. And what we learned is that doing something bad and doing something good can make the difference of about 50,000 euros a month, which is a lot of money, actually, for 1 point of data. So, again, this is also the management slide, the summary for everyone who wants to start computing the value of their data to reduce their databases. So first you need some kind of business impact, and I keep saying this because many people say this is so hard to do, or we see that it's good, or sometimes it's something like this, but it's really a good idea to try to find a decent measure that you actually can track regularly for your database systems. And sensitivity analysis is a standard method that's not widely used for this purpose, but you can use it actually to find out what in your dataset is really important. And then you just have to check whether this somehow correlates with your wishes. So our wish is to make more money, like maybe other people have the wish to create more engagement, for example, or put systems in that somehow make people go faster through a loop or something. But for us it's money, and then you have to check whether this means actual better performance. I have one last example for toxic data that we found, which is actually quite neat, because you know this everlasting fight buzz between salespeople and tech people. So we did a new round of that one because we found that some online marketing things can actually help boosting sales, but do not boost AI as much. So at Otto we have Deal des Tages, the deal of the day. It's every day, it's some product that is somehow discounted a lot. And by the way, once a year it's an iPhone, so now you have to check the page every day. And of course the deal of the day generates a lot of clicks, a lot of engagement. Everyone clicks on the deal of the day because they want to know what it is. But that also means the user doesn't do what the user actually needs right now or wants right now, but the user does what we tell him or her to do. And that means those user sessions that tell us which products are actually good fits for each other, they are somehow broken because we broke them, because we made users go somewhere, right? And actually we could have known before, but then we actually computed what happens. So look at the recommendations of a product before it was the deal of the day and afterwards. And then something like this happens. So this day with this break-in is the deal day, so to say, right? So you have to imagine the deal day. It's quite natural that the recommendations are really bad because people want to see the deal and not recommendations below the deal. So this was to be expected. But the other thing is that compared to the days before the deal of the day, the days afterward actually are much worse in terms of performance of the recommendations. So that means if an iPhone is the deal of the day, and we have some other smartphones below the iPhone, after it was deal of the day, the other recommendations below the iPhone won't perform as good. And this takes about 3 to 4 weeks until this is even again. So it would be a really good idea to filter their own marketing data out of the system that we actually build, assuming that a user somehow does something with his or her natural preferences. Because this is not a natural preference, because this is what we actually make them do, right? And here we can actually show this. This is a, well, prototypical example probably of toxic data that we produced ourselves. To conclude, so my case for data minimalism, or our case for data minimalism, is a case not only for cost reasons and because data is annoying and stuff, because it will always be a necessity. If databases are growing, you can't afford economically and ecologically to actually keep all those databases. And by the way, it also has social reasons, because every data point that you move somewhere through the network that you don't have to move is a security risk. So keeping the data points where they are is a good idea. The other thing is quality. So really knowing what the system actually needs has many quality aspects. The first is you can filter toxic data, but this is pretty easy. The other thing is you really have to know for this to happen what your algorithm does with the data. That means you have to explain and make your AI kind of explainable to actually be able to be a data minimalist. And this has a lot of other advantages too, besides being able to reduce the databases. And of course, this is rather difficult, and I would say it's rather interesting, but I think it's worth pursuing. So, let's do it. Thank you.